So here's an overview looking at elements and compounds. Elements and compounds are both pure substances. Elements only have one kind of atom in them, and compounds are going to have different kinds of atoms. And we can break elements into two different groups, atomic and molecular, and we can break compounds into two different groups, molecular and ionic compounds. And scientists tend to do that. We classify things and break them down into smaller groups, and you could do that with Legos. You could start out by breaking them down into colors. We'll put the red ones over here and the blue ones. Then you look at the blue ones and you see, oh, well, these are brick shaped, they're rectangular, and these are funny shaped ones, and those are people parts. And you divide things up that way, and it helps you to make sense of this big old mess that we call the universe. So the divisions within elements. Elements can be atomic or molecular, and these describe the smallest particles in those elements. Most elements are atomic, and they're found as single atoms as their basic unit. Some, though, are found as molecules, and we're going to talk about the diatomic ones. There are a couple of others. Sulfur and phosphorus do some funky things, and so does carbon. We won't go into those. We're just going to talk about the diatomic ones. So molecular elements exist as diatomic molecules. So di, what does that prefix mean? Two. So two atoms, molecules of two atoms. So here's an illustration. This is mercury. Mercury is very, very cool stuff. Sadly, it's also toxic. But mercury is a metal, and it's a liquid at room temperature. And so it's just crazy cool stuff. And if you were to zoom in, if you were able to, you would see that mercury is composed of individual atoms. And they're not particularly attached to one another in any specific way. They're just all there together. If we look at chlorine, though, chlorine is a diatomic element. And we zoom in on that, and we see that chlorine forms these distinct molecules. And there are two atoms in each molecule. These diatomic elements remind me of junior high girls. I don't know if you can remember back to junior high. But junior high girls don't like to go to the bathroom by themselves. In fact, you don't often find a junior high girl by herself anywhere. She always takes a friend. Do you remember that? I remember someone pointing that out when I was a junior high girl, and I still couldn't help myself. I'm like, wow, that's really true. So these diatomic elements are going to go everywhere in pairs, and they're not going to be found out by themselves. It's kind of like a buddy system. These are the 7 elements that occur as diatomic molecules. So whenever we have any of these elements by themselves, their formula is always going to have a subscript 2, meaning that there are 2 hydrogen atoms bonded together, or 2 oxygen atoms, or 2 fluorine atoms. And so we need to be able to remember which of those are diatomic. So there's 2 different ways to remember that. One is this, mnemonic. It's a silly sentence where the first letter of each word stands for something. And so these letters stand for the element symbols. So horses is for hydrogen. Horses need oats for clear brown eyes. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine. And this is a bit of a stretch, iodine. So I's and the letter I's, those are homonyms. They're not spelled the same, but we get the idea. Horses need oats for clear brown eyes. So if it's one of those elements by itself, it's molecular, it's diatomic. And if it's something else, then it'll just be an atomic element. Another way to remember this is by looking at the periodic table. So there are 7 of these guys. And if we find number 7, which is nitrogen, and we draw a 7 on the periodic table, do you see how that looks like a 7? Those are the diatomic elements, plus hydrogen. Because hydrogen is the baby brother, and he's got to be an exception to all the rules. So he's off here by himself. He's not with the others, but hydrogen is always diatomic as well. So you just need to learn those. So elements can be molecular or atomic. Compounds can be molecular or ionic. You can't have an atomic compound because then it wouldn't be a compound. So molecular compounds are formed when we have 2 or more nonmetals. And ionic compounds, we're going to have ions, and it's generally containing a metal, usually contains a metal. So we're going to learn how to recognize those. Here's an example, or two examples actually. Here's carbon dioxide, dry ice. Just carbon dioxide in the solid state is, we call it dry ice. This is a molecular compound. We look at the formula, it's got two nonmetals. That's going to be molecular. Carbon and oxygen, if they form ions, form negative ions. Two negative things would not attract each other, they would repel each other. Molecular compounds don't have ions, they don't have charges. So whenever we have just nonmetals, it's going to be a molecular compound. Over here we have an illustration of sodium chloride, or table salt. And looking in here we see that we've got sodium ions, the little purple ones, and chloride ions are the green ones. Sodium is a metal, it forms a +1 ion. Chloride is a nonmetal, it forms a negative ion. Opposites attract, so they'll stick together. That's an ionic compound. The basic unit of a molecular compound is a molecule. It's a little hard to see in that picture, but it's one red ball and two black balls. No, the other way around. One black, two reds. It's hard to see. But those are molecules. And for an ionic compound, the basic unit is called a formula unit. Because if we look at this, it's essentially one giant molecule. It's just an array of sodium chloride, sodium chloride, sodium chloride in 3 dimensions. And so you can't really say, well, here's a molecule and here's a molecule. They're not sitting there in individual pairs. And so it's not realistic to say, well, how many chlorine atoms and sodium atoms are in this piece and give it a formula, Na 537, Cl 537. It's kind of ridiculous. So we just go with the lowest ratio. And so there's always one sodium for every chlorine. So ionic compounds are composed of a metal and a nonmetal. So when you look at the formula for a compound, if there's a metal in it, it's ionic. The basic unit is called a formula unit, and as I mentioned, they have these 3-dimensional arrays. They're a little bit like magnetics. Have you guys played with magnetics? It's a magnetic building toy. It's got these little sticks and balls, and they're metallic and magnetic, and they all just stick together. And you can just build these huge things. And that's what ionic things do. Okay, so let's practice classifying substances. So the choices are atomic element, molecular compound, or ionic compound. So letter A, chlorine. What's that one? First of all, element or compound? It's an element, so we'll give it an E. Is it molecular or atomic? Horses need oats for clear brown eyes. It's molecular. It's one of the 7, so that's a molecular element. How about no? N-O. Element or compound? Compound. It has 2 capital letters. It's got to be a compound. Molecular or ionic? Molecular. Why? There's no metal in it. Nitrogen and oxygen are both nonmetals. In order for it to be ionic, it pretty much has to have a metal. How about gold? AU. That's an element. What kind of an element? Atomic. It's an atomic element because it's not one of the horses needs oats for clear brown eyes. There's an old show, there was an old TV show called Facts of Life. Did any of you ever watch the Facts of Life? No? Shoot. You guys are all too young. Anyway, there was this girl on there, and she's kind of a character, and it was about these girls at a boarding school, and she was trying to learn the element symbols. And she's like, well, gold is easy, because if somebody steals your gold, you say, hey, you, come back here with that. Okay. Yeah, that's okay. Okay, so Na2O. Compound. Ionic or molecular? Is there a metal in it? It's ionic. Okay, because sodium is a metal.
I was thinking nitrogen.
Oh, yeah. So you got to find it on the periodic table, and we got one on each wall, so I expect to see your head swiveling unless you have one at your table with you. But that's going to be ionic because sodium's a metal. If it was nitrogen, it would be molecular. How about CrCl3? That's a compound. Find Cr on the periodic table. Metal or nonmetal? Metal. So this is ionic. Ionic compounds are formed of ions. In order for ions to form a compound, you have to have a positive ion and a negative ion. The nonmetals form negative ions, and the metals form the positive ions. So if you have metals and nonmetals together, then you have an ionic compound. If you have two nonmetals, it can't be ionic because they would both be negative and they would not be attracted to each other. It'd be like having two north poles of magnets or two south poles. They're going to push each other away. That's not going to form a compound. Any questions?